For your homework tonight, you've been asked to correct your Chapter 8 review. We did some additional practice with transformations and functions and all sorts of things. So this is just a video aimed at helping you correct this work. So what we did first is we took a parent function here, y equals x squared. This is a quadratic function, and we moved it right 1. And so we remember to move something right 1 with a function, we have to do something to x, and we have to subtract from x if we want to move right. So we're going to have the equation y equals x minus 1 squared to move right 1. That means our vertex has changed. Originally it was at 0, 0, but if we've moved it right 1, we're going to now be at 1, 0. And then our domain and our range, we talked about these in class. The domain is all the possible x values we can have. And so in this case, we can use all real numbers as x values. This is a curve, right? It kind of looks like this, except we moved it to the right one, so it's a little bit over. And so we can use any possible input value, any x value. When it comes to range, we might notice again here that it's going to start at 0 and go up. So my y values are greater than or equal to 0. Now we're going to move to the right one and up 5. So y equals x minus 1 squared. That's going to again move it right 1, and then up 5 we're going to do a plus 5. Our vertex coordinates now have moved, right? So we went over 1 to go right 1, and now we've gone up 5, and so this is kind of moved like this over here. And so our new vertex is going to be at 1, 5. And our domain has remained the same, just all real numbers. Our range has changed because now we have a different set of numbers that will work for range values. So starting at 5 and going up. So y is greater than or equal to 5. For the next part, we want to do right 1, up 5, and a vertical stretch by 3. So we're going to write the equation y equals 3 to cause the vertical stretch to happen, x minus 1 squared to cause it to move right 1, and plus 5 to move up 5. Now our vertex, if you think about what's happening here, we're stretching it, so it's kind of like we're making it a little bit skinnier here, and that is not going to change our vertex point. It's just going to stay at 1, 5. Our domain is going to remain all real numbers, and our range is going to remain y is greater than or equal to 5. Next, we're going to do right 1, up 5, vertical stretch by 3, and reflect over the x-axis. So this equation is going to look like y equals negative 3, x minus 1 squared, plus 5. So you'll see here this negative is making me reflect over the x-axis. And so one of the things we were talking about today too is that in reality, we're going to deal with that reflection first. So we would take our curve here. I know this looks a little bit sloppy, sorry. We're going to reflect it first, and then we would deal with our stretching and our translations. And so I know it's a little bit funny to reflect it here at the end, and it might help for you to think about reflecting it first and moving it to make sense of the fact that the vertex actually should not be changing from where it was previously. So if you imagine reflecting it first and then moving it right 1 and up 5, right, we would get this kind of shape here. And we can see that the vertex point is still at 1, 5. It's now just going down instead of up. And so our domain continues to be all real numbers. And our y values, you'll notice now, start at 5 and go down. So y values are less than or equal to 5. Now let's graph the equation of our final transformation. So again, we have y equals negative 3, x minus 1 squared, plus 5. So again, I'm going to graph my vertex point first, which is at 1, 5. And I'm just going to use a scale of 1. And then there's a stretch by a factor of 3, and it's going down. So I'm expecting it to be a downward facing kind of U shape. And so I'm going to think about how normally I would go over 1 and down 1, because 1 squared would be 1. But if I'm stretching by a factor of 3, I'm going to go over 1 and down 3. Same thing if I think about 2, normally 2 squared would be 4. But in this case, we're going to do 2 squared is 4, but times 3 is going to become 12. And so you'll notice I can't actually even fit that quite on here, but I'm just going to kind of give a general idea of what the shape is. and that's perfect. We're going to do the same thing with the absolute value function here. So to move it right one, we're going to do x minus 1 inside of absolute value signs. Our vertex is going to be the same as before. We've moved it right 1, so 1, 0. Domain is all real numbers. And our range is y values greater than or equal to 0. For the next one, we're going to move it up up to the right 1 and up 5. So again, this looks very similar to the x squared function we just did, but we just want to help you see how it looks like with the absolute value function instead. The vertex is now moved to 1, 5 since it went up 5. Domain is all real numbers. Range is y is greater than or equal to, not 0, greater than or equal to 5, because we've now moved it up. And next we're going to also do the stretch by 3. So y equals 3 times the absolute value of x minus 1 plus 5. Vertex has stayed in the same spot, it's just stretching. It's still all real numbers, and it's still y values that are greater than or equal to 5. And lastly, we're going to deal with that reflecting. So y equals negative 3, absolute value of x minus 1 plus 5. Our vertex again remains the same as what it was. We still have all real numbers as the domain, but now that it's flipped over, it's now going to be y is less than or equal to 5. So just to graph that, again, we've got a point here at 1, 5. And looking at this here, again, normally it was the absolute value of 1 would be 1 here, but we're doing 3 times that. So now it's going to be a straight line right here. Absolute value of 2 was 2, but we're going to do 3 times that, so it's now going to become 6. So here I'm going to go all the way down here so you can kind of see how it's changing. And it's a mirror image on the other side. And so that would be my function. All right, now we're going to deal with a quadratic function moving a little bit differently. So if we move left 6, we're going to have y equals x plus 6 squared. Again, it's kind of like you do the opposite inside of a function. So to move left 6, we're going to do plus 6. So we've now moved left 6. So our vertex is at negative 6, 0. Our domain is going to be all real numbers. And thinking about our range here, it's still at 0 on the y-axis. So it's going to be y is greater than or equal to 0 because it's still that upward facing curve. Now we're going to move left 6 and down 2. So y equals x plus 6 squared, and then we're going to subtract 2 to move down 2. So that's changed our vertex. Now our vertex is going to be negative 6, and then we're moving down 2, so negative 2. So I know it's a little hard to imagine on our graph over here since it has a slightly smaller scale if you go by ones, but we might just modify that here in a second. We have a domain of all real numbers, and our range has changed a little bit since we went down 2. So we have y is greater than or equal to negative 2 because it shifted a little bit below the y-axis and we want to include those values. Now we're going to move left 6 down 2 and have a vertical shrink by a half. So y equals 1/2 for the shrink factor, x plus 6 squared to move it left 6, and minus 2 to move it down 2. And our vertex is remaining in the same spot. Our domain and our range are still the same. So all real numbers, and y is greater than or equal to negative 2. The next part we were going to do is to reflect over the y-axis. And we were talking about this a little bit in class. And the best thing I can think of to kind of help explain what we were talking about too is if we're going to make our function reflect over the y-axis, then what we've been talking about in class is how you have to think about with y equals f of x, you want to make the x values negative, right? That would cause it to reflect over the y-axis. And so the tricky part in this function that some of you noticed is if we make our x in here negative, it kind of throws everything off a little bit because it's not quite moving it the way we intend it to move. However, if you think about how negative x squared is going to make a positive x, it might be easier to kind of picture it that way. So I would just keep the same equation because negative x squared is still going to be a positive x. And when we think about this, when we reflect over the y-axis, when it comes to the x squared function, it's kind of like it just goes on top of itself, because this goes over here and this goes over here. It just kind of flip-flops. And so really there shouldn't be any change in what we see with our function. So our vertex is going to stay the same at -6, -2. We're still going to have all real numbers as our domain. And again, we didn't flip over the x-axis, so our range also remains the same. So when we graph it finally, again, it might help to use a slightly different scale here since the vertex is at -6. So I'm going to go here by 2's, so -2, -4, -6. And so I'm at -6, and I'll just go by 1's here, so -1, -2. So here's my vertex point at -6, -2. And then if I start plugging in some other points here, I can think about how I have a shrink factor of 1/2. So if I go over 1, I should be going up 1/2, right? Because regularly 1 squared is 1, but half of that would be 1/2. Regularly 2 squared is 4, but I'm going to do half of that, so it would be at 2. And so again, I kind of have my little graph kind of started here. Notice that it should still be in the shape of a curve, right? It's not going to be the absolute value straight lines. Let's go ahead and look at our next transformation with the absolute value function. Again, this is very similar to the one before. We just want you to see how it works with the same transformations, but a different parent function. So to move left 6, we're going to add 6 to x. Our vertex then is going to be 6 left, so we're going to have -6, 0 as the vertex. Domain is all real numbers. And our range is y is greater than or equal to 0, right? Because we can have any possible y values that are larger than 0. We're going to move left 6 and down 2, so y equals the absolute value of x plus 6 to move left 6, and then -2 to move down 2. Our vertex coordinates are now going to be -6, -2, because again we've moved to the left 6 and we've moved down 2. Our domain continues to be all real numbers. Our range, since we've moved down 2, means that we're going to be including some numbers that are below the x-axis. So now we can have y values that are greater than or equal to -2. Again, this should look familiar from the problem we just did. Now we're going to move left 6 down 2 and have a vertical shrink by 1/2. So y equals 1/2, absolute value x plus 6 minus 2. Again, that does each part. Shrink by 1/2, add 6 to move 6 to the left, minus 2 to move down 2. Our vertex is remaining in the same spot, -6, -2. We continue to have all real numbers as our domain, and our range is y is greater than or equal to -2. That hasn't changed. It was just a shrink. And then finally, we're going to reflect over the y-axis. So again, think about what we were talking about earlier. We have y equals 1/2. Regularly, we would make this a -x, but we have to kind of recognize that the absolute value of -x is going to be a positive x. So we're going to use x plus 6 and then minus 2. And so we'll keep the same vertex coordinates, -6, -2. We'll keep our same domain, all real numbers, and we will keep the same range. Y is greater than or equal to -2. So then same thing with the scale here. You might want to go by -2's, for example, on the x-axis, and -1's on the y-axis. And so I've got my point here at -6, -2. And again, I'm going to think about how normally this absolute value of 1 would be 1, but it's half of that, so it's going to be 1/2. Normally the absolute value of 2 would be 2, but it's half of that, so it would be 1. And so I'm just kind of sketching that line here so I can see what's happening. And hopefully that makes sense to you in terms of how we graph that function. Now let's practice describing how this function is being transformed. So when I take away 6 from x, that's going to move it right 6. And when I add 2 at the end, that causes it to move up 2. On b, when I put this negative in front of the f, I'm causing it to reflect over the x-axis. The plus 3 is causing my x values to move to the left 3. And then my minus 1 is causing my entire function to move down 1. For c, we have a vertical stretch by a factor of 3. And then we have minus 8 at the end, so we're going to be moving down 8. For d, I start with a negative, and again, that negative is telling me that I'm reflecting over the x-axis. And the minus 4 that is done to the x means that my x values are going to be going 4 to the right. For the last one, I see the 1/2. That's telling me that I have a vertical shrink of 1/2. And then I see that negative in front of my x. That would be a reflect over the y-axis. And finally, I see a +9. That's going to be moving up 9. Now we're going to solve the following equations and inequalities, and if there's no solution, we're going to write no solution. Remember that all these equations are either going to have two solutions because they involve squaring or absolute value, or no solution. Nothing is going to have just one solution, so keep an eye out for that. So we're going to go ahead and try to isolate our squared function or isolate our absolute value to start. So I'm going to go ahead and add 3 to each side. I'm left with x plus 4 squared equals 49. And to undo my squared, I'm going to do the square root. So I'm going to do the square root of x squared, or sorry, the square root of x plus 4 squared. That's going to leave me with x plus 4. And the square root of 49 is going to leave me with plus or minus 7. So a positive 7 or a negative 7. So now I can write my two equations. X plus 4 equals 7, and x plus 4 equals negative 7. And I'm going to solve both of them. So if I subtract 4 from each side, I get x equals 3. And if I subtract 4 from each side on the other one, I get x equals negative 11. And again, I can plug in both of those solutions just to make sure that they work. And that's a really good idea to test. So for example, 3 plus 4 would be 7. 7 squared would be 49. 49 minus 3 would be 46. So I can see it balances. If I plug in negative 11 plus 4 would be negative 7. Negative 7 squared would be 49. And 49 minus 3 would be 46. So again, it's always really good to check. For the next one, again, we're going to try to isolate our absolute value. So we're going to add 40 to each side. So then we have 2 times the absolute value of x minus 4 equals 50. Now I'm going to divide by 2 on each side. So I'm left with the absolute value of x minus 4 equals 25. And so again, I'm going to know that x minus 4 could be a positive 25, or x minus 4 could be a negative 25, right? Because the absolute value, whatever's in there, has to make a positive 25. So I'm going to add 4 to each side, and I get x equals 29. And here I'm going to add 4 to each side, and I get x equals negative 21. Again, it's a great idea to plug those in and just make sure that they actually work. And then for C, we're going to work on isolating our absolute value. So here we get the absolute value of x plus 4 equals negative 14. Well, I could try to keep going there, but I see a problem. Can you tell what it is? The absolute value of something has to be positive. So unfortunately, this one has no solution because there's no number where I can find the absolute value and create a negative value. For D, we have an inequality, which we're going to solve similar to an equation. Remember again that it should have two solutions. So I'm going to subtract 3 from each side. I get x minus 4 squared is less than or equal to 25. I'm going to square root both sides. So I have x minus 4 is less than or equal to positive or negative 5. Except, let's not write positive or negative 5. Let's just write 5 right now. So we need two expressions here, or two inequalities here. So x minus 4 is less than or equal to 5. And then remember, we also write a second one. X minus 4 is greater than or equal to negative 5. So we flip the sign of the inequality, and we flip the sign of the number. And so now we're going to go ahead and continue solving through. So I'm going to add 4 to each side. So x could be less than or equal to 9. And on the other side, I'm going to add 4. X could be greater than or equal to negative 1. So again, I can test those out as well. I could take a number that's less than 9, for example, or equal to 9, and plug it in and see if it makes my statement true. I could also take a number that's greater than negative 1 and see if that makes it true. Now we're going to evaluate some functions. First, we have g of negative 3. So one of the biggest challenges I've seen so far with people working on these equations is that they forget to put the negative 3 inside of parentheses and square it. So negative 3 squared minus 2 times negative 3 plus 4. So there's two x's there that we have to substitute for. So negative 3 squared is positive 9. Negative 2 times negative 3 would be positive 6, and then plus 4. So if we add all those together, we should get an answer of 19. For B, we're asked to find x if f of x equals negative 10. So remember, f of x is going to be our y value, so this tells us this is the output. So negative 10 equals, and we're going to set it equal to the f function, negative 6x plus 2, and now we can solve through. So we're going to subtract 2 from each side, we get negative 12 equals negative 6x, divide by negative 6 on each side, and I get x equals positive 2. And again, I can always check that. I could plug in a positive 2 up here as an input. So negative 6 times 2 would give me negative 12. Negative 12 plus 2 would give me negative 10. Right? That would verify that that solution is correct. For C, I have f of negative b. That might look a little strange at first, but it just means to plug in a variable. So instead of writing negative 6 times x, I'll write negative 6 times negative b plus 2. When I multiply negative 6 by negative b, we get positive 6b, right? Because the negatives will cancel out, plus 2. So that's just my final answer there, 6b plus 2. All right, D looks a little bit intimidating at first, but again, we're just going to go a step at a time. So we're going to start by finding g of negative 1. So we're going to plug in negative 1 squared minus 2 times negative 1 plus 4. So negative 1 squared is 1, negative 2 plus 4 times negative 1 is positive 2, and then plus 4. So we get an answer here of 7. And now we're going to do f of 7, right? So after we found g of negative 1 was 7, now we're going to do f of 7. So plugging it into the f function, we have negative 6 times 7 plus 2. So negative 42 plus 2 would give us negative 40. For E, we have f of 2 minus 1. So we're going to evaluate f of 2 first. So negative 6 times 2 plus 2, we get negative 12 plus 2, which gives us negative 10. And now we're going to just subtract 1. So negative 10 minus 1 would give us negative 11. For the final problem on your review, you've been asked to graph 4 points and connect them as your function. So I'm going to do a sample one here, but you might do something different. So I'm going to put 4 points here, 1, 2, 3, and 4, and I'm just going to kind of connect them together to create a little function for myself. So my original coordinates here, I'm just going to go by ones. Again, you could do something different. I have negative 3, 3. That's my first point here. I have 0, 2, and I have 1, 1, and I have 2, 1. So those are my original coordinates. So now I'm going to do something to this. I'm going to apply a transformation. So this is telling me that I want my function, I'm going to take my points, I have x plus 3. So within a function, if I do x plus 3, that means I'm moving 3 to the left. And so what I have to think about is, with my points, how do I move it 3 to the left? So that's dealing with my x coordinates. If I want to move it 3 to the left, I'm going to subtract 3 from my x values. So negative 3 minus 3 would be negative 6. 0 minus 3 would be negative 3. 1 minus 3 would be negative 2. And 2 minus 3 would be negative 1. So I've now moved those, right, 3 to the left. And so if you imagine here, this is actually going to be going a little bit off of my grid right here. And then I'm going to be also moving minus 2, which means down 2. So I'm going to subtract 2 from my y coordinates. So looking at what I have here, 3 minus 2 would give me 1, 2 minus 2 would give me 0, and 1 minus 2 would give me negative 1. 1 minus 2 would give me negative 1. So I'm going to graph this just to prove that it worked. So I'm expecting that it moves left and down. So I've got negative 6, 1. So I'm going over to negative 6 and up to 1. So I kind of have to imagine it's right there. Negative 3, 0, right here. Okay. Then I have negative 2, negative 1, and negative 1, negative 1. So I'm hoping you can see here how everything has moved to the left and down, just like we asked it to within the transformation directions. Now we're going to do our second image. And so this time we have a couple things. We have a reflection happening here, right over the x-axis. We also have a shrink factor, and we also have a reflection over the y-axis. So just to make it interesting. So when we do a vertical shrink, we are going to be multiplying by the y value, the y coordinate. So I'm going back to my original. So let's just kind of recopy what we had for a second. So when I deal with -3, 3, I'm going to be multiplying my y coordinates here. These are my y coordinates by a half because I want to make them half the size. So 3 times a half would be 1.5. 2 times a half would be 1. 1 times a half would be a half. And 1 times a half, again, would be a half. So now I got to think about what else is happening here with those reflections, right? 2 reflections, just to make it interesting. So I need to basically do the opposite sign of my x and the opposite sign of my y. So originally -3 was my x here, so it's going to become a +3. And originally my y was positive, so it's going to become negative, right? 0 is just 0, it stays the same. Originally my 2 over here was positive, so my 1 here is going to be negative. Over here I had both positives, so now it's going to be -1 and -0.5. And same thing over here, both of these were positive, so I'm going to have -2 and -0.5. Okay, so now is the test to see if I did it correctly. So now I'm going to plot my points, so 3 over 3, and then down 1.5. I have 0, -1, so stay at 0 and go down -1. And then I have -1, -0.5, so back 1, down 0.5, and -2, -0.5. So here we go, -2, -0.5. And so you can kind of see here, I know it looks a little interesting, right? It has reflected over both axes, right? So it reflected this way, and then it reflected this way, and then we also shrunk it by a factor of 1/2. I know this one is especially challenging, so definitely give it a shot and see what you find, and make sure you have all of your images graphed here. And we will see you Monday. My class, Mrs. Armstrong's class, will be testing on Tuesday, so please bring any questions that you have for our test on Monday. And Mrs. Wright's class will be testing on Monday, so hopefully this is an extra study resource for you. See you then.